Okay, so I just did a little hardness test, and I haven't actually found the outcome out yet. I did one scratch test with a different diamond, um, and it wasn't sharp enough. This one's really sharp, um, and so I put it on my piece of what I think is aluminum oxide, and if it is, that should be like a scratch. And I will not lick the rock. Me and the radium girls. And there is actually no scratch. So this is probably something like AUPT. Mm. Or maybe my aluminum oxide is 10 on the Mohs scale of hardness. I don't know. Um, sure looks like aluminum oxide to me. Hmm. What I need to do is take some pictures. I can take pictures of these reflections, and then I can do a spectrum on the light that they reflect, and that tells me what's inside the stone, or at least on the surface, um, to a large extent. Planes of cleavage also allow addressing in memory. Okay, memory is stored in magnetic on-off switches, so it's north and south, right? North and south is the same thing. And AUPT is a bunch of gold and platinum atoms all lined up north and south with each other, and they're all lined up on top of each other, kind of in interspersed, and that is they um, skip a space and move over one in the symmetry. Um, in each next row, right? They jog over one so that there's face centered. That means that there's a four around the thing and one in the middle, right? Except it's not four; it's six. Six at the places where you would put faces on a box, on a cube. Okay, so you can store memory. You can address it because it's all lined up in perfect little rows and columns. So if I know where the address of one thing is with X, Y, and Z, then I can address everything else because it's predictable. And I can not only store memory, I can manipulate it at a distance because it's magnetic. And because it's a room temperature superconductor, it doesn't take really, really, really big currents to make it do what it does. It's kind of like a self-powered cell phone to your best friend with one eye. And he grinned. learning. I just learn a day at a time. I don't know anything now. And this guy, he's got patience. And when I first met him, he says, "Have you been studying?" And I said, "Yes, sir." He said, "Been studying chemistry?" I said, "Yes, sir." And the interview was pretty much over, and he's been showing me. He also tells me he would prefer speaking in Mandarin, so I'm going to learn Mandarin this year. And we will speak Mandarin. Because it's a room temperature superconductor, and it's gold and platinum, but its value is because it's a room temperature superconductor. Its value is because it's so spectacularly cubic. So you can address those cubes as memory, or as like the screen on a computer. Exactly like the screen on a computer. And interestingly, when our benevolent government finally got inside the ship and after the third weapon was detonated, we went from, my father used to build electronics, all kinds of cool shit. My brother built a cloud chamber for his 8th grade science project. It was at the dependent housing at the Naval Postgraduate School, so he had competition, sure enough. But my father built electronics with tubes, right? I had an amplifier in my bedroom when I was a kid, teenager, that had these two huge power tubes that glowed blue at night, turn off all the lights and listen to the doors, boom, bum, 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 and have fun. And so, these things are dynamic. They change, if you notice, because there's somebody else on the other end, and he's a goofy old man. I love him dearly. I love him dearly. We're gonna change the world, he and I. We're gonna give it back to the people.